Alright, my friend, we are going to do a lightning review of structures. Now, first things first, let's go over virtual work. Now, this is pretty easy. When we're thinking about virtual work, it's virtual, so it's not real. It's something that we come up with to solve the problem. So for example, in this problem over here, we have a load over here, P, right? And the question in this example from the test is to find the reaction at point B, okay? We don't care about A or D. So if we're asked to find the reaction at point B, we know that there's going to be a force upwards, right? Because this guy is pushing down, so there must be some force upwards. We'll call it RB for reaction. Okay? So now the principle of virtual work states that we have to treat the system as if it's moving. There's 1 degree of freedom here, which means that this thing can only go up or down. And the way that I know this is because there's a hinge here. And a hinge will prevent the system from moving side to side. So 2 degrees of freedom would be up and down and side to side. A degree of freedom is just the directions it can move. It could also rotate. That would be another degree of freedom. But here we just have vertical motion. So here RB. Next thing that we're going to do is we have to kind of visualize this system. So if this is A over here, let's say that the deflection is going to be upwards, okay? Just hypothetically speaking. It'll be downwards in reality, but when we analyze it, upwards would be easier to analyze. So we expect it, if this is the horizontal line right here, we expect it to look something like this. If this is B, and this is D, right here, we expect it to look something like this. Boom. Right? And then it will go all the way up to point C. C right here is a hinge. And a hinge, what it does is just it connects 2 elements together. So the maximum deflection will always occur at a hinge. Okay, and then it drops back down over here. And now the next thing we'll do, let me pick a different color, is we mark the deflections. So this one we're going to call delta B for the deflection at B. Here we'll call delta C. And here we'll call it delta, we can call it like delta P or something. Delta P for the load. Okay, so now we're basically almost done with this. Now we just gotta look at the, what's it called? We gotta look at the triangles. So this is basically the easiest part. Okay, so from what I see here, look, this distance is A, right? This distance right here is A, and this distance over here is L1, correct? Correct. And this angle is shared by this small triangle and this big triangle, right? So we can use the similar triangles thing, and so we can say that delta B over A is going to be equal to delta C over L1, right? Similarly, if we look here, this guy is X, and this guy is L2. So we follow the same logic. If these guys share the same angle because they are similar triangles, then we can say that delta P over X equals delta C over L2. Okay, you see what I did there? Now, what is the common denominator in all of this? Delta C. We can equate the delta C's together, right? So if I solve for delta C on both sides, what I get from this guy is delta C equals delta B L1 over A. And from this guy I get delta C equals delta P L2 over X. Okay? So now what I'm going to do is I'm going to set them equal to each other. So delta P L2 over X equals, and then the one above was delta B L1 over A. Delta B L1 over A. So this is equation number 1. Equation number 2. Principle of virtual work says, principle of virtual work says that the virtual works must be equal to each other or must sum to 0. So the sum of all the work, virtual work, is usually written as delta W equals 0. This is the principle of virtual work. And work, if you remember, work is force times distance. Okay? It has units of newtons meters, if you want to think of it like that. So, what is the force here? Well, the force, obviously, we have two forces going on. We have RB, and then this deflection, that's the distance, delta B, and we also have this force, this thing doesn't scroll. We have P over here, and the deflection delta P. So, what I'm trying to say is that, okay, what's going on here? What I'm trying to say is that if you sum all the virtual works, so sum delta Wi is going to give us RB times delta B. That's the virtual work from this member at B, equals, and now we have delta P. So this is equal to P times delta P. Okay? I hope you can see what I did there. So now the last part is we just have to substitute. Okay? So we substitute delta B and delta P in here. And that's the last step. Okay, so check this out. Oh my god, this thing is so buggy. Okay, check this out. It doesn't matter, pick one. I'll pick delta B. So, RB, okay, what's going on here? RB times delta B, but what's delta B? Delta B is just delta P L2A over L1X. L1X. Okay, you see what I did there? I just solved for delta B. And this is equal to P times delta P. And now look what happens. This guy cancels out with this guy. And what are we left with? Hold on, this thing. What are we left with? We're left with just RB. So, in conclusion, we solve for RB. It's equal to P L1X over L2A. And that's our answer. So, principle of virtual work. The sum of all the virtual works on a system, okay, has to be equal to 0. Or, if it's only 2, they have to be equal to each other. So what we did here is, we singled out this member because that's what the question was asking for. The question was asking for, what is the reaction at point B? So we replaced this B, we replaced it with a reaction force, RB. After that, we look at what would happen if it would undergo what's called a virtual displacement. And this would be the virtual displacement. So we labeled delta B, delta C, and delta P. From there, what did we do? We used similar triangles. Okay? We used similar triangles to find a relationship between the deflections. And this led to this result over here. After that, we used the principle of virtual work to equal these guys to each other. And then we just simply substituted them in, and we solved for the reaction. Okay? So that's the first lesson.